Review of polar coordinates. In polar coordinates, we have a pole, which is a point, and a polar axis. So here we have point and a polar axis. A point in polar coordinate system is represented by the distance r from the pole and an angle theta. So we can have a point that has, let's say, 2 and 45 degree. Theta can be represented either in degrees or in radians. So we can place this in the polar coordinate system. This is my pole and polar axis. So this angle is 45 degree, and we measure two distances from the pole. Here we have the pole. If r is negative, then the point is on the other side of the pole. So if I have the point that is -2 and let's say 45 degree, then we have the polar axis. We measure 45 degree, which is half of 90 degree, and instead of going two distances to the right, we go on the other side of the pole. So we measure 1, 2, and here is my point. Here is my point that is -2 and 45 degree. As we know, polar representation is not unique. That means a point can have several polar coordinates, like 45 degree or -45 degree. If we have a point that is 2 and -45 degree, which gonna be -45 is this way. So we can always write this, as an angle, either opposite angle. Like this example, if I would like to plot it, here's my polar axis, 45 degree, -45 degrees right here. So the point has two distances to this right. We can also find this angle. And have the negative on the other side. So this one is 90 plus 45. That gives me 145 degree plus 90 degree gives me 135 degree. So this point can be written as -2 and 135 degree, because I can find the angle 135 and put on the other side. So one point can have several representations. That means it's not unique. And we have example 1, plot the point and find other coordinates, r and theta, for which r is positive but theta is a negative, and we would like to plot -2 and 5 pi over 6. So let's try to plot it. We have the polar axis, and we need to plot 5 pi over 6. So if I am opening my angle, as we were doing before, here is 90 degree, here's 180. 180 is pi, and we are short of pi 1/6 to have 5 pi 6. So here would be pi, but we have 5/6, so we are short of 1/6 to have 6 over 6, right? Because 6 over 6 pi is 1 pi. So 5 pi over 6 is right here. So the angle is -2. It's going to be on the opposite side. So we have 1, 2 right here. So this is the point -2 and 5 pi over 6. The angle 5 pi over 6 is right here. This point. And we would like to rewrite this point using positive radius but negative angle. So negative angle is right here. Negative angle is right here. And what is that angle? Pi over 6. negative pi over 6, because the reference angle is pi over 6 right here. So we can write this point. This point has coordinates 2 and negative pi over 6. That would be the other representation, r positive and theta negative, between minus pi and minus 2 pi and 0. Now from polar coordinates, we need to be able to convert from polar coordinates to rectangular coordinates, and in that case we use the formula x is equal to r cos theta, y is equal to r sine theta. If we have given r and theta, those formulae comes from this triangle. We can place the polar axis in rectangular system. So here is my p, that p is angle theta. The angle has theta, and the distance from the pole is r. So p in rectangular coordinates, this is my x and this is my y. And to get the first one, we were using cosine is adjacent over hypotenuse, which is x over r, and we can solve it for x. And the same story we did for y coordinates. Y is opposite over hypotenuse, it's sine, and solve it for y. So if we have given polar coordinates r and theta, and we need to find x and y, we use this formula. Now, to convert from rectangular coordinates to polar coordinates, we use this formula. So in that case, we have given x and y, and we are looking for r and theta. So r, we can use Pythagorean theorem right here, and theta we can use given the y and x. In that case, given is y, x and y. So opposite over adjacent is tangent function. Now we have example. Find the rectangular coordinates of the point 2 and 3 pi over 4. So this is my polar coordinates. So the first coordinates in polar is r. R is equal to 2. Second coordinates is theta. Theta is equal to 3 pi over 4. And now we can apply the formulae. X is equal to r cos, y is equal to r sine. So we have that x is equal to r cos theta, and y is equal to r sine theta. So in that case, we can just substitute. X is equal to my r is 2 cos 3 pi over 4, and my y is 2 times sine 3 pi over 4. Now we need to find this cos 3 pi over 4. So the best way is to draw the angle 3 pi over 4. So opening up to here, we have pi in terms of fourths. So 4 over 4 is 1 pi. So 3/4, that means we are short of 1/4. So here is 1/4 pi, or pi over 4. So this angle is 3 pi over 4. So my reference angle, theta reference, is this angle pi over 4. And we know that all trigonometric functions are equivalent to the same trigonometric function of a reference angle up to the sign, plus or minus. And to determine, we go with the quadrant add sugar to coffee. So in the second quadrant, whereas my angle 3/4 pi, on the sign is positive. So this one is equal to negative cos of the reference angle. So x is equal 2 times minus cos of pi over 4. We get that minus because cos in this quadrant is negative. because only sine is positive. And for this one, we get y is equal to 2 times sine of the reference angle, which is pi over 4. Sine in the second quadrant is positive, so we have sine positive. The rest we need to find from the chart. Make your chart. So cosine theta pi over 4 is root 2 over 2. We have root 2 over 2. Square root 2 over 2. So my x is equal 2 times minus square root 2 over 2. And sine pi over 4 is also root 2 over 2. So we have that y is equal 2 times root 2 over 2. And root 2 we can at 2 we can write that this is over 1, this is over 1, then this 2 and 2 reduces to 1, the same story right here. So we have that x x is equal to negative root 2 and y is equal to root 2. So the rectangular coordinates is x and y, which is negative root 2 and root 2. We need to be able to convert from polar to rectangular. In that case, we are using r cos theta and r sin theta. And now we need to be able to convert opposite way. Find the polar coordinates of the point. So in that case, we have rectangular coordinates. So this is my x, this is my x, this is my y, root 3 over and 1. So my x is root 3 and my y is 1. It is good to plot the point to see in what quadrant we are, at least approximately. So root 3, if we punch on calculator, is roughly around 1.5, 1.7 or 6. So if I have 1, somewhere here is going to be root 3 and 1 on the y-axis. So here is my point that has coordinates root 3 and 1. Okay, so we are in the first quadrant. We need to find r. You can use the triangle. This is my x distance, this is my y distance. So in that case, we are using the second set of formulae that we just talked about, that once we have convert from rectangular to polar, r squared is equal to x squared plus y squared, and then the tangent relation. So first I'm going to find r using Pythagorean theorem. R squared is equal to x squared plus y squared. I'm going to substitute my values. So we have that r squared is equal to square root of 3 squared plus 1 squared. Square root of 3 squared is 3. So we have that r squared is 3 plus 1, which is 4. So r is equal to plus or minus root 4, which is plus or minus 2. But because r is considered a distance from the pole, so r is equal to 2. R can be negative, then means the distance is on the other side. So then we would need to probably find this angle. But we concentrate on positive, so we take only the first quadrant angle. Now we can use that tangent theta is equal to opposite, which is y. Here's my theta over x. So tangent theta is equal to 1 over root 3. Now we need our chart. Make your chart. So in that case, 1 over root 3 tangent is pi over 6 or 30 degree. So my theta is equal to pi over 6 or 30 degree. Since we are in the first quadrant, the chart is always giving us the reference angle, which is the first quadrant angle. So polar coordinates of this point on my given point are r and theta, which is 2 and pi over 6.